Good day, students. Now, today we are going to see chapter called alternating current, which is important chapter in the NEET physics section. So, alternating current, what it deals, what it is going to deal. It goes to see how the current varies for the various phases with respect to resistance in the capacitor and inductor. So, when the various in the inductor resistance is added, what happened to the alternating current? This session we are going to see in detail in this NEET physics session. So, now we are going to say alternate current. So, everybody knows that. Last week also I think I started with the alternating current. So, alternating current and DC current. So, DC current is a direct current, alternating is the AC is the alternating current. So, the main difference between AC and DC is DC has the main application only in the, so especially in the industry. Okay, that industry is like railway, but here we are having the home appliances. So, AC current. So, this I already told you? No, this is the first time I am telling.
No, sir, you said already.
This I already. Oh, in the revision part I told you. In the revision part I told you. So that's not counted because this is main class, only this is counted, okay? That's a revision, okay? So this is so AC current you know everything in the home appliances. This is the home appliances. In the home appliances compared to industry is the one where you need the huge amount of power. So when a huge amount of power is needed, you have to go for only DC. Here there's not that much thing. Of course, we can use directly because it will be very expensive. Okay, we have to go for very cheap because we are having a home. How many ration card is there in Tamil Nadu? In Tamil Nadu, how many ration card? How many family members? One ration card has at least 5 members, husband and wife and 2 or 3 kids, minimum 2 kids. So it will have at least 5 members. So that means one ration card has this much means this much family members. That means India, Tamil Nadu government has almost 1.5 crore ration card. That means for 1.5 crore people they have to supply the electricity. Okay, so now approximately they will get every 2 months they will get 5,000 rupees means average they are getting average every family is paying 2,500 rupees electricity bill to the Tamil Nadu government. So that ration card is a ration card. That means in Tamil Nadu 1.5 crore ration card is there. That means 1.5 crore into 5. How much? 1.5 crore into 5. 7.5 crores. That means almost 7.5 crore people is average there. These 1.5 crore people, family people, they paying the tax as well as the current bill. They paying averagely 2,500 rupees electricity bill. So 1.5 crore into 2,500 rupees, 1.5 crore into 2,500 rupees. So you can calculate. So 1 crore into 1,000 something, around it will be around 1,000 crore or 2,000 crore, something like that. 2,000 crore per month. Per month, all family members paying their electricity bill only. Okay, this is nowhere related to the ration card. Ration card is a statistical. How many people are getting the food? How many people having the family, the members? In members, just to get the members, from that we can calculate the electricity bill. Just so for that they are paying. See, every month they are paying 2,500 rupees. So will anybody can every month can all the family members will pay 25,000 rupees or 2.5 lakhs per month to the family members. No, to the government. 2.5 lakhs they have to pay to every month to the EB bill or Tamil Nadu government bill. So is it possible? Is it possible to pay 2.5 lakhs per month? Why? Everybody knows that this is not possible. Okay, they have to pay everything. It should be very cheap. Then only they can run the family. Okay, so that's the difference between AC and DC. Instead of that, if they spend DC, what they will do? What is it? It's very expensive. Yes, let us assume Tamil Nadu government is sending here DC. Okay, instead of AC. So how much electricity bill you have to pay per month? 2.5. Every not only here. To all the family members has to pay 2.5 lakhs to the every month to the EB electricity board, they have to pay nearly to, it's very, very expensive. So for to overcome only, AC was introduced. Now you comes, who is introduced current and who is introduced AC current? Do you have any idea? Huh? AC? AC current is Tesla. Who discovered current is invented by current actually invented by Thomas Edison. Direct current. So Edison only introduced the direct current. Okay, direct current, which is in around middle 1860s. Around 1860s, he got the patent for that. Okay, he only introduced the bulb also in the bulb. Okay, see in the just simple bulb. In the bulb also he has introduced everything. Huh? He? Huh? What? That's okay. See, that and all we don't want. He suffered 1,000 times. He suffered 10,000 times. That and all we don't want. Who discovered it? Edison discovered that. That's all. See, we have to write exam. Who is discovered? They will ask. They will write. That's all. Is it he suffered 1,000 times? It's not that much easy. Is it easy to discover a bulb? Is it easy to discover electric? If you take the electric train, right? This also is not easy. Now we are running it. It was introduced almost in the 1970s. They introduced. Okay. What we are running by electric train between beach station to the Chengalpet is a electric train. Okay. That electric train, and what is going from outside of the to city, connecting city to city, is a diesel engine. Okay, that principle is different from this principle. This was introduced by 1970s, and this was introduced by late 2000 or late to the or we can introduce early of this century, 2001, 2002, 2003, around that period. Before that, it was running by everything was running by the diesel engine was introduced by early 2000 thing. Before that, cola. What is the name of the machine? Steam engine. Steam engine was thing where you want to go to. Anybody travel from here to Madurai, here to Delhi, Calcutta, Delhi, Bombay, Calcutta, etc. Did anybody travel? No, sir. Before 2000, not recent times. Before you are not born at the time. Yeah, you are not born at the time. If you are born at the time, if you are born before that, those who have traveled before that, they might have traveled with taken steam engine. Okay. Then the century 2000 was shifted. Okay. Then they shifted to the diesel engine. So now now if anybody travel, if you are anybody traveling, okay, to Bombay or Delhi, something you can go, something like that. For example, let us assume today you are traveling. Today you are going to travel to Delhi. Okay, so around 6 o'clock is the train. Okay, if the 6 o'clock is the train, what will happen? They will 6 o'clock. They will till I think in Renigunda they will change. I think Renigunda. Do you know what is Renigunda? Train station. Renigunda, there is one station near Tirupati. Okay, it's near to Andhra border. It's Tamil Nadu to Andhra border. When it started from Chennai, it will not stop there nowhere. But in Renigunda, it will stop for nearly half an hour. Okay, then it will go for again. It will start this journey. But in Renigunda is the turning. Okay, why they will stop at half an hour in Renigunda? Yeah, can anybody tell why they will stop? Nearly they will stop all the train. Any train express train, whether from Delhi, Mumbai, etc., which is passing through Renigunda, they will stop at half an hour. They will stop for nearly half an hour. For every station, they will stop for one minute. 1 minute or 2 minutes, they will stop all the station. Okay, but in only Renigunda, they will stop for half an hour, because from Chennai to Renigunda, electric, they will use the electric engine. Okay, electric engine similar to here. Okay, but after that there is no current supply. So they'll change the engine. Now the change is from electric engine, they will change to the diesel engine. After that, till it reach to, for example, going to Mumbai, going to Delhi means I think till Lucknow, I think. Till Lucknow, Chennai to Lucknow, okay? Chennai to Renigunda, Renigunda to Lucknow. Till Lucknow, it will run by diesel engine only, no electricity, no electric wire, nothing. Then after Lucknow only, they halt for half an hour. They will change that engine to electric engine. From Lucknow to Delhi, it's electric engine. So like that they will change. So only two options is there now: electric engine and diesel engine. That's all. So that so this was this both the thing was vanished by the before the early 2000. There is no problem at all. Before 2000 there is no problem at all. 2000 before 2000, you know, steam engine, okay? Steam engine was there, that was running fully from Chennai to Delhi. No interchange, nothing. Now now it has changed everything. So they'll change the timetable according to that. So that means a new concept was introduced. New concept was introduced, which is electric engine and diesel engine. And what is advantage? What is advantage compared to steam engine? Time travel. Time travel is very fast. Steam engine is not that much time travel. Instead of, if for example, if Delhi takes 24 hours, 48, there are 3 days it will take. Now it will take in 1 day. Only thing, they will halt for half an hour, that's all. And another is load consumption. Load, it will consume more it will consume more coal. That means for 1 kilometer how much it consuming, the diesel they have to pay almost 10 times less. So for example, it's traveling 100 kilometers, okay? Chennai to Delhi, 1000 I think 2000 kilometers something, 2000 kilometer. So 2000 kilometer means 100 they have to split it. They 100 for example, 2000 kilometer means how many coal it consumes. So if for 100 kilometer, how many coals is consumed? What it consumes for 100 kilometer, diesel will consume almost 10 times of it less. So what is the price you are paying for coal for 100 kilometer? Here the same diesel, you have to pay 1/10 of it. So it will be reduced almost 10 times. For example, coal, how much coal costs? 1 kg. 1 kg is 50 rupees. Okay, for 100 kilometers traveling, let us assume it has consumed almost 10 kg. 10 kg, not 10 kg, something around 50 rupees into 10 kg. Okay, let us assume 500 rupees. So for 100 kilometers, it has consumed, coal has consumed 500 rupees. Okay, so price. Now here comes same 100 kilometers is there, and in the same 100 kilometers, diesel you have to put, means you can put it is just 1 liter is sufficient. 1 liter, what is the 1 liter of diesel? Something 100 rupees. 100 rupees. So this will be you put half liter of diesel. That's sufficient. That will cross 100 kilometers. So here it is 500 rupees. Here it is a half liter of diesel. So what is the difference now? Difference in amount? 1 liter is 100 rupees. A half liter is 50 rupees. So here diesel consumed only 50 rupees. Here it is 500 rupees. So the diesel the price is now decreased. So that's why they introduced that. Then time factor. It will take a lot of time. And this will take less time. So time consumption. So these two are the main important factor. So these are the various factors by which things. Now we come for AC and DC. AC and DC. So yes, DC is the one that has the DC is the one. So that's expensive. Yeah. What for are we discussing this? Yeah, for expensive. So we don't want nobody can pay that much amount. It will be very expensive. So only simple thing what we got is AC. So AC current has various advantages compared to DC. See, for example, they introduced chapter 7. What is this chapter? What is, I think chapter 7, I think. This one, something else, chapter 7, alternating current. And what is next chapter is? Electromagnetic induction. They didn't introduce, after introducing what they you didn't ask. I didn't think so. Did you ever ask why they introduced alternating current instead of DC current? Or after introducing alternate current, they might next chapter they might introduce DC current. No, they didn't introduce DC current. Why they didn't introduce DC current? No, that's different. That's for your understanding.
In DC current only the current
Why why see they introduce alternate current this chapter. Next chapter they should have introduced DC current. No, why they did introduce? Huh? 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 Yeah, we can use it in the electric train, right? All electric train, all railway engine. See, railway, you know, one engine. You forget about this electric train, okay? You forget about this electric train. It's of no government has no not that much benefited. That passenger train. No, what do you tell that express train? No, Chennai to Delhi. What is that train name? What do you tell? Chennai to Delhi, Chennai to Delhi, Chennai to Mumbai, Chennai to Calcutta. Express train, I think. Okay, express train. So this train versus express train. So that is traveling from this connecting the cities. Okay, this is within India, within city. That is outside city. The government has main profit is through that only, because one engine they fitted and almost there will be 10 compartment. All something 10 in that, out of only one compartment, one or two compartment. One compartment is unreserved and one is for luggage. So out of 20 compartment, 2 or 3 you skip it. So they will have 15 compartments. 15 compartments they getting huge amount of money. Huge what they spend it, they have to spend only for the diesel they have to spend. Then for the electricity, then for electricity they have to spend. So after all the expenditure, what they're getting profit, they pay for one train. For example, the train is moving from Chennai to Delhi. Today's train is moving evening 6 o'clock. Then it reached 6 to 6. I think 6 to next day it will take, I think, 36 hours, 1.5 days it will take to reach Delhi. Okay, 36 hours it has traveled, 36 hours it has traveled, which is 1.5 days. Government spend it, diesel. Then what are the other spend? Electricity. Then diesel. Okay, electricity is very negligible. You assume that diesel, sir. So diesel and what are the other expenditure for the train? Drivers and guards salary, okay, etc. Then electricity, etc. After all the expenditure, after all expenditure, how much profit they getting? No, they getting almost 80%. What they getting? The profit of one train from the railway is getting is almost 80%. Because for Chennai to Delhi is for one person it will cost, I think, around 1,000 rupees. For in AC it costs around 3,000 rupees. For a double tire it costs 5,000 rupees. So totally 15 compartments. 15 compartments. So this is the investment and profit. They are getting almost 80% of profit only. So for one train itself they are getting this much of profit. So like that everything is profit. Okay. So what question I ask now?
Why are they
Huh? Why they introduce? Let us assume they introduce AC current. Next chapter they might have introduced DC current. No, electromagnetic induction is different. Don't tell that electromagnetic induction is DC current. Okay, that's different. Okay, so that's different. So that means why they didn't introduce? They might have introduced, no. So DC current, it's only with respect to high voltage appliances. Unless otherwise it's heavy movement is there, it is not be applicable. So heavy movement is where is the heavy movement? Huh? Heavy movement. Huh? Yeah, right, train. Only train has the main application because it has one engine connected to 20 compartments. All 20 compartments. Even luggage also is money to government. Luggage, no? Luggage compartment. They will send parcel from Delhi, Chennai to Delhi, Delhi to thing. They will not even single space is not left in the train. Everything is money. Everything they money. Government wants money. They invested they constructed the train and tracks. They invested the money. They get a huge amount of money. Railway is getting huge amount of money. Everything is from money. Everything is money. So the even luggage compartment they will not leave. Which is luggage compartment will be at the end. Okay, they will not leave that also. That also is money for government. So everything is money for government. So they did introduce. It's only for the not for the commercial purpose. It's not for commercial purpose. It's only in the industrial point of view. So here it is commercial purpose. Here I'm sitting here. Okay, I'm sitting here. What is the current here and what is the voltage here? 220 volt is a common volt. Common. Okay. Then current is maximum current. Maximum current is 15 amps. 15 amps, 220 volt. Okay, frequency is 50 hertz. Okay, so this where you can find this information. You can find this information in the board, in the where electric board or any choke if you take, it will be there. In where you plugging, what you tell that you where you plug it that thing. What is that name? Huh? No,
Meter box.
no,
Choke.
no. What is you want to such plug? You want to plug it, laptop, anything, bulb, anything to that thing. What is that name? Switch box. Switch box. So switch box you will have that plug, no, switch and plug it will come. Okay, there it will be given the details. At the back side it will be given. Okay, so it's 3 whatever is there. See whatever in the house is there. I am having house. Whether the house is anywhere in Tamil Nadu. Okay, yeah, you can go from Chennai or to Kanyakumari. The maximum current they will provide is 15 amps and voltage is 220 volts. Frequency is 50 hertz. Okay, so this is the main basics of the alternating current. So if this is the main basis of the alternating current, this point till now when we started the class? 9:30. 9:10. Okay, 9:10, 9:40. So almost half an hour over. You understand all the concept. So if you not understand all the concepts, just tell me. I'll repeat once again in Tamil. So now the AC current. Now I am taking the circuit. Okay, any circuit you can take. Okay, circuit is taking which is only AC current, not about anything. You need not worry about DC current at all. DC current is entirely different. We are not even going to discuss also DC current. Okay, so AC current I am taking and adding the something resistance. This resistance you know. Okay. V is directionally proportional to I. So now V is equal to, what is this? V is equal to IR. What is this? What is this? Huh? Ohm's law. V is equal to IR. So now did you get that a copy? 150 pages plus 2? Both the copies. Why? Otherwise it will be very, very difficult. You have to learn before coming to the class. It has all the details. In addition, I will be discussing in detail here also. Okay? So, did you discuss, did you, why you didn't take? It will be difficult for you. Why are you going to print? No, you told me no. Today you will be receiving it, something like that. Okay, okay. Did I told this no? Edison discovered the current which is direct current. You know, right? I told you no. Then Tesla only discovered the AC current. Tesla is a student of Edison. Edison already got the patent. There is a conflict between his teacher and a student. Okay, so he wants to start a new experiment. He don't want to work with Edison. So he went to another place, started new experiment, discover the AC. So that is this only AC. So that is the application of this AC. Finally, it is home application came in the by AC only. So AC across resistor. So first we go for V is equal to Vm sin omega t. How I got IR here?
Ohm's law.
Ohm's law. V is equal to IR. Just now in last equation I derived V is equal to IR. So is equal to Vm sin omega t. So I is equal to now I is equal to Vm by R sin omega t. So I is equal to Im sin omega. I is equal to Im sin omega t. Vm by R is equal to Im. No.
I equal to V by R.
Yeah, I is equal to V by R. Im is equal to Vm by R. That is I maximum. This is the current maximum. What are the two types of current you can expect in the house? Current? No, not two types of current.
High voltage.
No. Higher value and lower value of the current. Huh? In here, what is the two types of value we can expect?
220 to 50 volts.
Higher current, not voltage. If you take, if home is appliance, no, it will come with two types of current. Okay, it's 15 amps and 5 amps. Here this socket is there, right? all the sockets will be 5 amps, but it's the AC, not fridge and all you can, fish to washing machine, everything. AC and generator, what is that? Heater, not generator, heater, water heater, right? Water geyser they will take. Water in the bathroom heater or geyser, it will be 15 amps, and AC, no, that will be 15 amps. So these two are 15 amps, and this one is the this one, all other things, everything can run in 5 amps. Only this 2 is there, that's all, other than 2 is there. So which is maximum here? Which is maximum? Huh? Yeah, 15 amps is the maximum. Minimum is 5 amps. So that's a difference now. So now V is equal to Vm by sin omega t is equal to IR. I is equal to Vm by R sin omega t. Okay. Now Vm by R, how I can write? Vm by R, how Im, because maximum value. This one is only current, this one is the maximum value. So I is equal to Im sin omega t. So Im is equal to Vm by R. Power is equal to I square R, which is I square R sin R sin square omega t. So sin square here sin square omega t is off. Okay. So P is equal to I square R. This is same equation only, I think. Im square by R sin square omega t is equal to off. Sin square omega t is off. So off into Im square into R. Okay. So that is sin square omega t is off. Okay. So I substitute this, I am getting off. Now what value I will get now? Im square into R into off. So I will get now of Im square R. So Im now of Im square is a capital I, which is I square R. So power is equal to now I square R. That's all. Power is equal to I square R. Okay? Huh? Okay? Okay? This is visible. Huh? Okay. This is, I think it's not visible. I think this one. This.
Last step of math.
Huh?
Last equation.
Okay. Ah. Now we are going to see AC across the inductor. Inductor is a type of resistance. Okay. So if the resistance, first what we seen AC is the AC. First what we seen AC across AC resistance is connected across the AC. Now what we going to see, inductor is connected across the AC. Now next one what we going to see is a capacitor. Capacitor is the one that connected across a series. So what is it now? Resistance. Resistance, you know. What is the definition for resistance? Definition for resistance. What is the definition for resistance? You know? Okay. This resistance is a one that will act as that will reduce the flow of current. Resistance is the one that will reduce the flow of current. Okay. So this one is the inductor. Inductor also is a inductor is a type of resistance that will also decrease the flow of current. Then next one is capacitor. What is definition of capacitor? Store the energy. Store the type of storage energy. So energy store means so in energy storage means what will happen now? It will store. It's a type of capacitor is a type of what is that medium, I think. Okay, media. It's a capacitor is a type of material. That used to store the energy. So now with respect to current, what will happen now? If it stores the energy, huh? Current will be resta. Current will be increased. You can increase the current. You might know that tubelight, right? Light tubelight in the house. Okay, all the tubelight they will be in the sound in the now it's not available. I think now even all the tubelights. I don't think so. You have seen it. In the olden days it will come tube light. Now the tube light that are coming are LED. So you don't need capacitor now. Do you have what kind of tube light you have now?
Normal.
Common tube light.
Normal.
Normal tube light. You know, normal tube light is coming now. It's not because that all vanished, I think. So now the tube lights all are coming is rare. It's very rare. Not in the city. Probably in the out of city they will be available. In the normal for LED no problem. LED is entirely different.
Normal tube light, it's type of
Small circle type of a thing you will know. That's a capacitor they will tell, and they will attach to the tube light.
because the high voltage of current and the tube it fuse point.
Huh?
Fuse point adu illana current.
It will not fuse at all.
Adu illana
No, it will not be fuse. Nothing will happen to it. Okay? That is when there is a current fluctuation, voltage fluctuation is there. That will be voltage fluctuation is there. What is V is equal to IR? V is equal to IR. When the voltage is fluctuated, what happens to the current? V is equal to V is equal to IR. V is equal to IR. V is directly proportional to I. When there is a fluctuation in the voltage, what happened to the current? Current also will be fluctuated. That means if the voltage decreases, current also will decreases. Okay. So if the current decreases, what the capacitor will do? The capacitor will increase the current, because it has a few percentage of the type of capacitor is something to store the charge. It will charge it. It's a type of battery. What is the purpose of battery? To store the current. Like this, it will store the current, and it will be releasing when there is a voltage fluctuation. When there is a voltage is fluctuated, the current will be released. Okay. So this is the normal thing. Nowadays it's not coming. Everything is vanished. So everything is vanished. Finally, a LED bulb is came. You don't need that capacitor in the LED bulb at all. The circuit is entirely different. Okay. So what here we come for the inductor. What is inductor? Inductor is also type of resistance. Okay. So inductor is a type of resistance. Will it decrease the flow of current or will increase the flow of current? Decrease the flow of current. Resistance is a type of resistance. Okay. So it will decrease the flow of current. So it will decrease the flow of current. So if it decrease the flow of current, how we can calculate the power? How we can calculate the power? No, this one is P. Okay, don't confuse with this. This is different from this. Okay, P is equal to. Okay, now V is equal to Vm sin omega t. V by L, V by Vm by L is equal to I is equal to Im sin omega t minus pi by t, because voltage and okay, this one is the voltage, this one is the current, and current and voltages, how many what is the phase difference? Phase difference, this one is pi and this one is 2 pi. Okay, so this voltage is started here and it's ended in the here, so it completed one cycle. Okay, so one cycle is completed means what is the total phase difference? What is the total phase difference of voltage? You understood my question? First is voltage is started. This is what is the starting phase here? 0. And what is the maximum amplitude is reached? What is the maximum amplitude is reached? And where did it reach? Then where it is reached the 0? Where it reached at the 0?
Pi.
Pi. then again it's traveling and again it's reached the 2 pi. 2 pi is how, what is it? What is the 2 pi? 2 pi is 180. So 2 pi. What is pi?
Pi
360 degree. That means it's completed one cycle. Voltage is completed one cycle. Now I am introducing the current here. Current in what is the inductor? In inductor current and what this is pi. Traveling the half of it. So what is here? Angle will be here. Pi by 2. So this is now. This point is pi by 2. So this point is pi by 2. That means voltage and current. What is the difference between voltage and current now? Pi by 2 in inductor. In inductor, the current and voltage will travel across the difference of pi by 2. So pi by 2. So now sin omega t minus pi by 2 is equal to Im is equal P is PL. PL is equal to IV Im sin omega t pi by 2 into Vm sin omega t. Okay. So this one is Im sin omega t minus pi by 2 and Vm sin omega t. So what I will get now? Im Vm, this one Im and Vm cos sin omega t by minus pi by 2 is cos omega t and sin omega t. So if I substitute this value, I will get minus Im cos omega t is 1 by 2. So I minus Im by Vm by 2 into sin 2 omega. Okay. So you taken this? You taken this? So can I up? बराबर. now first now what we are going to see AC voltage for the capacitor. So already what we see, first one is the resistance, second is inductor, third is the capacitor. So the capacitor V is equal to Q by C, voltage is equal to Q by C. Q is the charge, C is the capacitance. No, capacitance, not capacitor. Capacitance. This is a capacitor. It is added. What we added is capacitor, and the quality is Q, V is equal to Q by C, which is capacitor. So V is equal to Q by C, which is charge by capacitance. So Vm is equal to V is equal to Vm sin omega t Q by C. So I is equal to dQ by dt, which is C into, so dQ by dQ by dt. Okay. Now what is the value of Q here? What is the value of Q here? C into, not charge, it's not a charge. Q is the charge, C is the capacitance. So capacitance into Vm into sin omega t. So Vm sin omega t, C into sin omega t. C is the constant value, so we have to take outside. So C into d by dt, Vm sin omega t. So in this scenario, what I am getting, so differentiation of sin omega t is nothing but cos omega t. So is equal to cos omega t, and differentiation of omega t is omega. So what I will get now here, C is constant here, Vm cos omega t into omega, which is omega C Vm cos omega t, and in this Vm cos omega t. So did you understand this topic? Huh? Did you understand or not? It is a step by step calculation. Okay, step by step calculation. Did you understand or not? You understand. You understand. If you not understand, just tell me. I repeat once again. That's all. This is a full max calculation, mathematical calculation. Okay. First I am taking V is equal to Q by C. Vm you know very well. V is equal to Vm sin omega t Q by C. So I is equal to dQ by dt equal to C into dt dou by dou t Vm sin omega t. Okay. Since Vm, so it will be Vm cos sin omega, differentiation of sin omega t is cos omega t. So but when you differentiate the omega t, you will get omega outside. Okay, so you will get omega outside, t will be 1. Okay, so it will be, now what I will get now, C is there, omega which is get it here. Actually omega will be, omega into C into Vm into cos omega t. Did you understand how you got omega C Vm cos omega t? Did you understand or not? Huh? Did you understand or not? Okay, just you have to differentiate. First you have to differentiate sin omega t, you will get cos omega t. Then you have to differentiate omega t. You have to differentiate omega t. So if you differentiate omega t, you will get omega, not t. Why? T is 1, because you are differentiating your omega t you are differentiating. So when you differentiate omega t, you will get only omega, not t. T will become 1. You will get omega into 1. Omega into 1, nothing but omega. So you will get omega C Vm cos omega t. Here it is, current is passing towards here. The first you will take for voltage. Voltage is here it is 0, then it's traveling maximum amplitude, then reaching the pi, then it reaching the lower amplitude, then it reaching the 2 pi. Okay, 2 pi. So now, now if you take the current, where it is passing now? It's in passing between 0 and pi, okay, which is nothing but pi by 2. Pi by 2. So it's passing between the 0 and pi, okay. So pi by 2. So if it passes between the pi by 2, what will happen? Now I is equal to Im sin omega plus pi by 2. So Im is equal to here it is I C Vm is equal to I omega. So I is equal to Im sin omega t plus pi by 2. Okay. So now Im is equal to Vm by Xc. Xc is the capacitance value. Okay. So PC, what is PC? PC is the power of the capacitance. Power of the capacitance is equal to I into V. I into V is equal to Im cos omega t plus Vm sin omega t. Okay. So V you know, okay. With this V you know, V is equal to Vm sin omega t, and I is equal to Im cos omega t. Okay. I is equal to Im cos omega t. So Im is equal here it is, or I will write here itself. Okay. Here it is I is equal to what? Omega c Vm. What is omega c Vm? Im, correct. Im, that is here. Im is equal to omega c Vm. So I is equal to Im cos omega t. So PC is equal to I into V. I is equal to I omega Im cos omega t. V is equal to Vm sin omega t. So if I multiply both, what will get? Im Vm cos omega t sin omega t. So if you take this, finally you will get PC is equal to Im minus of. I think cos omega t is minus of. Okay. So minus 1 by 2 into Im Vm sin 2 omega t. Okay.
Yes, sir.
So you are taking this.
Yes, sir.
You understand all this equation, derivation, everything?
Yes, sir.
Okay. If you are not understanding, just tell me. I will explain once again in Tamil. Okay. Physics the concept wise, அதாவது எப்படின்னா இதை புரிஞ்சிக்கணும். இதை புரிஞ்சிங்கன்னா அந்த ஈக்குவேஷன்ஸ் எல்லாம் ஈக்குவல இதில் வந்து அந்த ப்ராப்ளம்ஸை சப்ஸ்டிட் பண்ணணும். ப்ராப்ளம்ஸை சப்ஸ்டிட் பண்ணணும். ப்ராப்ளம்ஸை சப்ஸ்டிட் பண்ணி இப்போ என்ன எடுத்தேன் நான்? ரெசிஸ்டன்ஸ். ஓகே. ரெசிஸ்டன்ஸ், இண்டக்டன்ஸ், கெப்பாசிட்டன்ஸ். ஸோ அதே மாதிரி அதை கொடுத்துருவாங்க. கெப்பாசிட்டன்ஸ் வேல்யூ கொடுத்துருவாங்க. வோல்டேஜ் கரண்ட் வேல்யூ, வோல்டேஜ் வேல்யூ எல்லாம் கொடுத்துருவாங்க. அதை சப்ஸ்டிட் பண்ணி அந்த ஈக்குவேஷன் எடுத்து மோஸ்ட்லி ப்ராப்ளம்ஸ் தான் வரும். ஆல்மோஸ்ட் 90% ப்ராப்ளம்ஸ் வரும். 90 to 80% வச்சுக்கலாம். 80% ப்ராப்ளம்ஸ் வரும். 80% ப்ராப்ளம்ஸ் வரும். 20% தியரி பார்ட்லேருந்து சம் கொஷின்ஸ் கேட்பாங்க. கொஷின் அண்ட் ஆன்சர் கேட்பாங்க. மோஸ்ட்லி 80% ப்ராப்ளம்ஸ் தான் வரும். ப்ராப்ளம்ஸ் இதுதான் சால்வ் பண்ண சொல்லுவாங்க. Now we go for this AC voltage. Now AC voltage comes across the LCR circuit. So now what I am going to do, I am attaching all the three now. Okay, this is source current AC voltage. So all the three I am attaching: resistance, capacitance, inductance. Okay, so if I attach the inductance, what will happen? IM is the, what is IM? Maximum current. VM is the maximum voltage. So maximum voltage, maximum current, then equal to divided by root of R square plus XL minus XY, XC minus XL. Okay, so R is the resistance, X is the capacitance, and XL is the inductance. Okay. Now we go for resonance. Resonance. No, what is doubt? Huh? Huh? Resonance. So resonance is the one by which you can take. So resonance, no? No, what is your doubt? Huh? Huh? கேள்விப்படாத பேரா இருக்கா? கேள்விப்படாத பேரா இருக்கா? சுத்தம். Oh, that's why you are murmuring. No, resonance. Okay, resonance. Now, what is resonance means? Okay. Resonance means what is the frequency? The frequency of the things is it should the frequency of any material you can take. You can take any material. Okay, any material. What material we can take? I think yeah, you can take this table itself. Anything. Okay, you forget about everything. Just simple resonance. What is first you have to define what is for the resonance, what is the definition? Okay, first you take this material. Okay, this material will resonate, it will show some frequency. Okay, this any material you can take where it is traveling with the maximum amplitude. Okay, maximum amplitude. For example, I am taking two wave. Okay, where it is traveling with the maximum amplitude. If maximum amplitude is, which has the highest amplitude here? Second one. Second one. That means where the material and coincide with the natural frequency. That is, when it's traveled with maximum amplitude, this will travel with the natural frequency. This will coincide with the natural frequency. So that is the resonance. Resonance means any material that having its own frequency that traveling with its own maximum amplitude. Maximum amplitude. So this is the wave this is traveling. These are the maximum amplitude. You know, right? Amplitude, frequency, wavelength, everything we discussed. I think we discussed or not. So amplitude, which is what is our definition for amplitude now? Amplitude. What is the definition for amplitude? Definition of amplitude? Oh, no, anything? No. I don't want that and all. Just you tell you orally what do you understand from amplitude? Amplitude. Frequency different. Height of the things. See, this is the wave where it is traveled maximum height. Amplitude is nothing but maximum height. That's what you tell me. See, when I ask the question, you have to answer according to that. What is the amplitude? It means the wave that is traveled to a maximum amplitude, maximum distance. So this is a wave. It traveled to the maximum distance is this. So it then finally traveled to the it is A. Okay. Then it traveled to the again is to the again it's traveled back, then it's traveled in the negative direction. Okay, then again it's traveled to the same, it attaches the wave. That means this is the wave that is completed one wave. When it's completed one cycle, so when it's completed one cycle, it is called lambda. That's all. This is the wavelength. This is lambda. This is amplitude. What is nu? Frequency. Frequency is equal to? No, frequency is number of oscillation. No, what is I am asking? What is the terms? Nu is equal to? 1 by lambda. This I explained, I think, in nu is equal to 1 by lambda. Lambda is nothing but completion of one cycle. Okay? So the completion. So the time taken to complete the one wave, time taken is t. What is t here? T is the time taken for the wave to complete the one wavelength. Time taken to complete the one wavelength. For example, I am taking two wave. This wave I take. Okay, simple I am taking. See, now you go here. Okay, this one is a lambda 1 because it's completed one cycle here, and this one is completed. This one is another second lambda 2. Now we are two option comes here. T1 is greater than T2. T2 is greater than T1. Which is correct? T1 is greater than T2. Here it is. I am taking two values for this. Okay, for this. T1 is greater than T2. Otherwise, T2 is greater than T1. T1 is T2 is greater than T1. Why it is T2? T2 greater than T1. What is T? T is the T is dependent upon the lambda value. Lambda value, that is the number of waves taken to complete one complete cycle is one wavelength. Okay, so T for here that lambda value will be higher. When lambda value higher means T2 will be higher because it has taken a lot of time to complete. Here the lambda value is lower. If it is lower means it will take the low time to complete the one wavelength. That's all. This is the way. So this and all these things. Where we discussed, I think this one in revision part we discussed. I think I teach you in the revision part. Okay, that same thing only I am again asking. You are telling oscillation is very new to you. No, what we are doing now? Resonance. We are discussing resonance now. See, again deviated now. Resonance. We are discussing now resonance. Nu 0 is equal to 1 by root of LC. Okay, nu 0 is a resonance frequency. Yeah, omega 0. Omega 0 is the resonance frequency. Resonance frequency. So the resonance frequency is equal to 1 by LC. What is C here? L is inductance into capacitance, root of inductance into capacitance. Okay, you taken?
Yes, sir.
Power factor in the AC circuit. Power factor is given by power is equal to V into I. Okay, Vm sin omega t. V is equal to Vm sin omega t. I is equal to Im sin omega t plus phi. Okay, now Vm by Im divided by 2 is equal to cos phi minus cos 2 omega t plus phi. Okay, then Vm by Im by 2 is equal to cos phi. Cos phi we can write as Vm by root 2. This 2 you can write as root of 2 into root of 2. Okay, root of 2 into root of 2. We can separate this 2. Okay, then cos into cos phi is equal to Vi cos phi. That is Vm by root of 2 is equal to V. Im by root of 2 is equal to I. Okay, which is cos phi. So is equal to cos I square. This one is I square. So this one is I square I square z. I square z. I square is at cos phi. Huh? Over? You take it? Over? So first one is P is equal to I square Z cos phi. I am attaching the resistance. Okay. If the resistance is attached, P is equal to I square cos phi is equal to I square Z into 1. Because so when I attach to the resistance, power is equal to I square into Z. Okay, into 1, which is nothing but I square Z. But same if I attach the L or C, it is P is equal to I square cos Z cos phi, which is 0. So now totally P is equal to 0. And converge to LCR. What is LCR? Capacitor, resistor, inductance. So phi is equal to tan inverse XC minus XL divided by R. What is R here? XC is capacitor, inductive capacitance. That is capacitance power. Okay. Then XL is inductive inductance. Okay. So LC oscillation. LC oscillation is a 1. You take this definition. LC oscillation is a 1 by which the capacitor and inductor LC oscillation is a 1 by which the capacitor and inductor stores the electrical and magnetic energy. Stores the electrical and magnetic energy. Okay, when capacitors is connected to the inductor, when capacitor what I told you first sentence,
When capacitor and inductor store the electric and magnetic energy.
when the capacitor and inductor can store the electrical and magnetic energy respectively, when capacitor is connected to the inductor, charge on the capacitor and current in the circuit exhibit a phenomenon of electrical oscillation. Charges in the charge in the capacitor and current in the circuit. Charge in the capacitor and current in the circuit exhibit the phenomenon of electrical oscillation. Oscillation, and this is called LC oscillation. This is called LC oscillation. So now this is LC oscillation. Now can I put a LCR oscillation? Now okay, first you tell first what you tell me, what is the definition I give? No, what is the definition I give?
Which one capacitor and inductor store electric energy?
Huh?
Store electric and magnetic energy.
The capacitor and the inductor can store the electrical energy and magnetic energy when the capacitor is connected to the inductor. Okay, when the capacitor and by which the charge on the capacitor and current in the circuit can exhibit the electrical oscillation. That is the LC oscillation. So what is LC oscillation tells now? LC oscillation tells that the electrical capacitor will store the electrical energy and magnetic inductance. No, what is it? No, inductor will store the inductor store the magnetic energy. Okay, when it can store when it can be stored when the capacitor and when the capacitor and inductor connected. So this is the LC oscillation, that is called LC oscillation. Now I am adding to the LCR oscillation. Is there anything called LCR oscillation? LCR oscillation. LCR oscillation is possible? No, it is not possible. Why it is not possible? Because when the capacitor and inductor connected, this will store the electric energy. and this will store the magnetic energy. So when this will store, when the LC oscillation only possible, LCR is not possible. When the LCR is added, everything will be collapsed. There is nothing. There is no possibility of LCR oscillation due to addition of resistors. So there is no right. Okay. There is no possibility of LCR oscillation. There is no possibility of LCR oscillation there is no possibility of LCR oscillation due to addition of resistor R, because due to addition of resistor R, because when the resistor R is added to the LC circuit, when the resistor is added to the LC circuit, what will happen? It will collapse the entire circuit, LCR circuit. When the resistance is added to the LC circuit, it will collapse the entire LCR circuit. So hence there is no LCR oscillation is possible. 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 So only possibility is now what? LC. Only possibility is now only LC. Only LC. And another possibility also exists. What is that? Is also not possible. What is the another possibility to that? Correct, RC. RC is not possible. LR is not possible. So there is no 3 possibility. 24 possibility. Okay. Totally is LC. Okay. RC. No, wait. See, LC, RC, LR. Then LCR. Okay. So all the 3, this 3. 4, total 4. Okay, LR. No, RC. So, what is another not possible?
RC, LR.
So this. Only LC is possible. That only I am telling. LC is possible. So RC, LR, LCR is not possible. Not possible. So it is not possible. Okay. So this is not possible. So only possibility is LC. So finally give V is equal to V. No, not V. U. U is equal to UE. U is equal to UE. U is equal to UE is equal to of QM square divided by C. Which is Q. What is QM here? Charge. This one is C is capacitance. 1 by 2 QM. So Q 1 by 2 QM square divided by C. Okay, you taken this? Yeah, finally transformer. So what is the application of transformer? High voltage to low voltage, low voltage to high voltage. So that's why it's called as a transformer. A step up and step down. So now transformer has two types, step down and step up and step down. Okay. Where you will be seeing in the every 10 streets, well, you can see you will be finding one transformer in every 10 streets. Okay, once in 10 streets you will find out one transformer. What is the purpose of adding that transformer here in the street? Huh? High voltage to low voltage. What is high voltage there? Low voltage is 220 volt. Okay. High voltage will be coming from where the current is produced? Huh? Power station. Okay. For us, what they are producing is, further what they are producing. Did you see that in the, I don't know where, no, not in the EB office, in the remote place and all, where there is no people will be living, will be very tall rod will be there, and a very long, plenty of wire will be coming there. Okay, you can't find it in the where humans are living or not, or peoples are living. It's a very big, it will be very big tower. Okay, very big tower. In that big wires will be thing. What is the purpose? What is the purpose of that wire and tower? It's a type of current transfer where the current is produced. For example, the nearest current where we are getting here is from Kalpakam. Okay, from Kalpakam, where is Kalpakam? Near to Mahabalipuram. So where they produce, once they produce the current, they will hand over the current to the state government. So the state government will take that current and supply to all the people. So what they will think is, they will not transfer via AC. Okay, what they will do it? What is the output of the current? What is first they have to produce the current. Once they produce the current, that's all their work. That the government work, central government work is over. Almost all the production will be run by central government only. Okay, they will give the current to the state government. That's all. After that, their government. How they will give the current to the state government? They will give in the, no, they will not give in the AC. That's all I am asking you. They will give in the form of DC. Okay, the state government, they will bring the current. Everything they will do it, the current, everything, the transformation will be in DC, not in the AC. Once it's reached to the outer skirts of the town. Outer skirts of the town means where? Outer skirts of the town, city, outer of the city. Okay, the Kalpakam is there. Okay, I am getting the current from Kalpakam. Okay, so the government produced it, current from the Kalpakam, and they given the current to the state government, which is EB board. Okay, EB board will be run by the state government. So all the government which they are producing current, they will give on the DC format. Okay, they will hand over to the DC. What they where they will convert the, so once the state government got the current, they will be getting so they will be getting, now the state government got the current. Okay, and from the where they will get the current, immediately they will not convert it to AC. They will be transforming via either DC format only. So they'll all the current is now getting in the DC only, where they will convert AC to the DC. That's why AC to the DC. That is the power of a transformer. So what you will be seeing in the out of the town. In the out of the town, you will be finding a very big tower like structure where there are some 10 wires will be coming. So what is the purpose? That purpose and all. That purpose is a DC current, where the current is transformed from the main station to the outside of where the current is transforming now, where the transformation of current is taking place. Transformation of the current is taking place. Once it reaches till it reaches the out of city, it will be DC only. So only in the outside of the DC, now outside of the DC, outskirts of the city, outside of the city, something like that, they'll split the current now. Okay, all this current will be splitted now. So all the current is splitted now. Also it will be the DC. So that's why you are finding, you will be finding every 10 streets you will have one transformer. What is the purpose of the transformer? And it's very in the lower part they will be written high voltage don't touch 25,000 watt it will be written. Till that it's a AC a DC current. Okay. Now only the transformer will convert the DC current to the AC current and supply to the all the home line appliances. So this is what the format. So when they produce the current, it's a DC. When they make the transformation, that also DC. Okay. Once it reaches the main city, they will split the current. Okay. Now only split the current. That also DC. Only after entering into the city, now only they will attach a transformer and they will convert the DC to AC. That's why in the wherever the transformer is there, in the bottom side they will be written 25,000 volt danger don't touch. They will tell. Okay, if you touch, can you survive if you touch this volt? Okay, can anybody survive? No. If you touch then 25,000 volt, what will happen now?
There is no.
Yeah, you will not get your body. You will get ash. That's a ash. You will get only ash. So that's the purpose of transformer. So the transformer is the one that will convert the voltage to high voltage to the low voltage. So almost like a DC to AC. Okay, DC to AC. So what? So now he comes for the step down and step up. So what is step up? Step up, step down. Huh?
Low voltage and high voltage.
Step up is the low voltage to the high voltage. Step down is the high voltage to the low voltage. Okay, you taken this? You taken? No, you taken or not?